All right, so next up is to talk about standard form of the quadratic function. Now, we've seen this a little bit before, right? Ax squared plus bx plus c, f of x equals that. That is our standard form. All right, easy enough. Don't know why I did that. There we go. So we'll change back to red, easier to see. So now, if you want to convert that to vertex form, you can complete the square. Shall I do it? Sure, why not? Right? So we can say, and I think maybe we did this before, I don't know. So we pull out a because we don't like to complete the square with something that's not a coefficient of 1. That means our x term is really a b over a. And I'm going to go throw c out here. So I need to figure out, hey, what am I going to add here to make this an x plus something quantity squared, right? So we've got to figure out what goes there. Now, so what we're going to do is we're going to go back to our box and we're going to say, okay, I got x squared here, and I have b over ax. So I really have to split that into two parts. So I got b over 2a, and I split it in half, and b over 2a x. So I've got x plus b over 2a, b over 2a, right? So does that work out? That gives me x times b over 2a. That's going to be b over 2ax. Add those two on the off diagonal, add together, gives me b over ax. And then what I've got to add to both sides is going to be what? B squared over 4a squared. So b squared over 4a squared. Now, that's what we added inside to complete the square. But we've really added a times that, right? So we've added b squared over 4a. So we've got to subtract b squared over 4a. Okay? So now we've got it in vertex form, right? Here we've got our h. We know what h is. It's b over 2a. And we know what our k is, our y vertex or y coordinate of the vertex is that lovely mess over there, right? So this is h. Oop, didn't mean to do that. Pen. Blue. All right, this is h, and this lovely mess is k. Okay, am I going to ask you to complete the square? No. What you can do is simply remember that the x coordinate of the vertex is at negative b over 2a using the a and the b from the standard form of the quadratic. Okay, and then the y coordinate is whatever you get when you plug that into the equation. Okay, so this is our h, and f of b, negative b over 2a, is our k, right? So, because remember here, this is really negative h, because we want this to be, sorry, I should have done this, minus a negative, right? Because that is our pattern for where's our vertex, because your movement is opposite to the sign. So there we go, negative b over 2a, this you guys want to remember, negative b over 2a, x coordinate of the vertex, okay? So I found this kind of summary here when I was looking for stuff online. I was like, hey, this is pretty good. I will put it in for you guys. So you've got standard form, you've got vertex form, and you've got factored form, otherwise known as intercept form. And each of them have their strengths, right? Standard form is going to tell you very quickly where the y-intercept is, because it's whatever c is, right? And you can find the vertex pretty easily. It's negative b over 2a. Okay, that's easy enough, right? If you're in vertex form, that's great because you know exactly where the vertex is. And that means you can graph it, a really simple graph, you know, where's the vertex? Does it point up? Does it point down? And, you know, if you want to get to standard form, you just multiply everything out. Now, intercept form is also very useful. That's your factored form because it will tell you exactly where your x-intercepts are. You just look at what your factors are. And then you say, well, where's the vertex located relative to those x-intercepts? And it has to be exactly in the middle. It has to be halfway because the thing's symmetric, right? So the vertex has to be exactly halfway between the two x-intercepts. So that means you can average your x-intercepts to get the x value for the vertex. Okay. So same story happens with standard form as far as if it goes up, if it opens up, it opens down. If your A is positive, your graph is concave up, opens up, the vertex is the minimum. If your A is negative, you've been reflected over the x-axis, the vertex is a maximum, it's concave down. If your A is between 0 and 1, it's been shrunk vertically and it looks wider, right? So we might say it maybe looks like that, right? And or like, or upside down, kind of like Amazon, right? And if it's greater than 1, then it looks very narrow, right? Might be up, might be down, depends on if it's positive or negative. So now we've got examples, but this is a good place to break because, I'm trying to keep these things short for you guys.